Okay, now you can share your screen.
Okay.
Okay, open to Ubuntu terminal. Okay. Now ls here and enter.
Okay.
Okay, open Pits Daily. ls here. Now what is 0 and 9? Okay, let me first of all check what is exact status of your simulation. Okay.
Okay.
Let's say RM is to delete minus RF is 9. Control that. Now this is where we can just start our simulation and start from 0 and at 2000 and roll is 1, right roll is 100. All things are good. Include only streamlines are included. Save this volume. Let me see this space. Question is converge. So we need to set our worst thing. Okay, copy paste at your desktop. Let me see whether it has any error or not. No, right here explorer.exe. Right here explorer.exe. Paste dot and copy and paste at your desktop.
Okay. Okay.
Open in Paraview.
I open x.form.
Yes.
That's fine.
Open next.form. Apply. So this is going to be happened in our. Yes, this is the thing. Okay, can you just this is not working directly? Can you just click our this right P? Yes, this one. Click at U. There is something error in this case. Why it is not working? It should work exact as we setting. Okay, let us check one more thing. Anything in boundary conditions or something? Can you click over this upper wall? Upper wall. Yes, so apply. And from here, only solid colors. Remove all things. Let me just, okay, let me give you this remote control.
Okay.
Over there. Solid color. And then this thing will apply for all. Go there. What is the boundary condition for them upper wall and whether are they empty? Open your Ubuntu terminal.
Okay.
Open your Ubuntu terminal. ls here.
1 second, please, because
ls here. Go to your system directory, cd system. Enter. Open your block mesh file vim space block mesh tick. Capital E. Back plane is empty. I cannot see lower wall and upper wall. Yeah, I have got it. Escape it. Press escape. Press escape. Yes, good. CD dot space enter. Right here, block mesh. Enter. Okay. Now right here, simple form and enter. Now copy and paste them at your desktop. Now there are no such. And delete which are already present at our desktop. Open in ParaView. Okay. Now click at front plane. Remove internal mesh. Remove internal mesh and click over at front plane. Click at front plane, apply. Remove front plane and click at inlet. Inlet, apply. This is inlet. And its values from this to this. Or click at outlet. Apply. Okay. Now click at walls. Apply. Good. Now click at scale. Apply. Okay, good. Now click at front plane, back plane, sorry, back plane. Back plane, apply. Okay, now click at front plane. Apply. Okay, now close. Good, now close it. Now close this thing. Close ParaView. Open your Ubuntu terminal. ls here. And now remove here and the directory 9. Right here, rm space minus rf 9. Enter. Now remove post processing. Right here, rm space minus rf post processing. Enter. Now ls here. Now open your system directory, cd space system. Enter ls here. Good. Okay. Now press cd space dot. Enter ls here. Now open your constant directory cd space right here see and enter ls here. Okay, now open transport properties vim trn right switch vim space trn enter. Okay, transport any and okay, now press escape shift colon wq. No need to change here, press escape shift colon wp enter ls here. Open turbulence properties vim space turbulence properties enter. Now just it will come down Ross K omega SST Ross K epsilon turbulence. Okay, press escape shift colon WQ. LS here. And now right here CD space polymesh. Enter LS here. Now right here VIM space boundary. It will come down. More inlet is patch, outlet is a patch. Okay, good. Back plan just it will come down. Back plan is empty. Okay, just come little down. Front plan is also empty. Okay, good. Next it will come down. Walls or wall. Okay, and scale is also wall. Good. Now okay. Scale is added. Walls are added. Front plan. Back plan. Okay, press escape shift colon W key. Escape shift colon W key. Press escape from your keyboard.
Yes, but okay, now yes.
CD space dot dot. CD space dot dot. Enter. Right here simple form. Enter. Solution is canonical after 9, but there is some error. Now ls here. Open your 0 directly cd space 0. ls here. Right here VIM space capital U. Enter. Inlet uniform. Our okay. Open your paraview for once for one. Open your paraview. Open the files which are present at your desktop. Load it. File open. Desktop. XFOAM. X.form. Okay. Apply. Okay. Now they are in the direction of positive. Okay. Good. Positive. X from this point to this is then that is a sign here. Good. Okay. Minimize this. Okay. Internal field. Okay. Right. Value is here. This is not the name. Okay. This little come down more. Front plan, back plan, index come down. Okay. Okay, just wait for 1 second. Let me check what error. Press escape, shift colon W2, and just go back at your main case. LS here. Now go to your system directory, cd space system. Enter ls here. Now open your FV scheme, right here VAM space FV schemes. Small s, not capital S. Small c, enter. Just it will come down. This is steady state, it will come down. More, more, good. More down, more down, more, more. Press escape shift colon W2. LS here. Enter. Now right here space VIM FV solution. FV solution. SO. Enter. It will come down. Okay, change this 10 power negative 6 in PUC tolerance at change this tolerance to 10 power 20 up in the P in PUC tolerance yes, change this to 10 minus 20, press I. Okay, 1E minus 0. So this is not 0, 2 0, remove 0. All right, here 2 0. Now same with the UK and epsilon. At the bottom you see tolerance 10E minus 0.5. Change them. No need to change it. Right at 0.1. In solver setting you see down, little down. Yes, more, one more. Yes, here. Change 20. 0.5 to 20. 20.
20. Okay.
What are you doing? I'm not understanding. What are you doing? Remove 0.05 right here. 1E minus 20.
1A
Minus 20. Remove. Okay, good. Now press escape shift colon W. CD. Enter. Enter. Right here simple form. Enter. What happened?
I don't know. In time 9 close. Finish.
Cannot see your screen. Okay.
What I
Give me your remote access.
okay.
The bonding in a key error in this. And epsilon error. CD 0 minus 0. So sound for
What is this?
This is the file which comes here and not the version. Space and
Why are you put 0? What is the meaning of that?
whether why my solution is not extracting right now, I am just
Mhm.
using to defining these values. Okay, these
Okay.
are by default values which will are causing problems in our simulation.
Yes, yes, I consider.
First of all, let it run, then we will check what happened to our okay. Now let me run and check whether it gave error again or not. Let's say, it was simple form or anything else. Let me check. This one. Uh, yes, it is simple form. No finite volume options are present.
The same problem.
So, just 1 second, Joseph.
Yes, yes, okay.
Okay. I think I have removed that files of zero directly CD 0 epsilon into all the value. Let me do it. Yes, this is 14.4. So it has some bounding box of minimum LS and let me go back to that and create LS and OpenFOAM CD space open form CD space open. Well, let me go to the tutorials and check their files. Compressible, simple, that is for the PS. And open the PS.
Dale.
CD, PID, LSA, CD, system, restart dot LSA, and go to zero directly first of all, LSA and capital. Oh, not this column. Simply directly file. No, to say VIM space capital
Mhm.
U. Okay, this is zero, uniform is zero. 10 is in this direction. Okay, there is no anything place action, but we are placing a block. Yes, I have got it. Okay. The problem is that we are placing a square at the center of our domain. Okay.
Yes.
But in this tutorial, the solver which is already written in here, they didn't place any block or any geometry in its domain. Let us try one more, but it should work here. Okay.
Okay.
14.85 is the value of this thing of epsilon. Okay. 14.85 column scale W and Q 14.5. Okay, and then enter. And then let's once again here and write here VAM space. Okay, 14.85 and 0.375. Okay, column WQ and enter. Sir, VIM space NUG. This is 0. Not sure what this thing. Anything else from here? VIM omega. 40.15. Yes, that's the reason. Okay, that's the only thing is that in this case, I got your point that they are using different turbulence model, whether it's K epsilon or K omega. So let us first check in our file which turbulence model we are using. In this case, CD bits LS CD space constant LS VIN turbulence properties. Okay, so we are using K epsilon right now. Okay, we are not
Mhm.
using K omega SST or anything else. First of all, let us change this to K omega and check what happened with this. Let me change here and this thing to K epsilon to K omega. Now let it be run and check what happened with our case. Okay,
Mhm.
K epsilon. I'm just changing my turbulence model right now. Oh,
Omega.
omega K omega. Press escape, fifth column, W2. And now I'm just saving the file. Okay, now let me just come back to this directory. Let's see. And let me write a simple code.
First, we not remove 9. Ah, okay, now.
Okay, now it start working. Okay, that is the reason our simulation was not working because I think we have used a wrong model or a wrong turbulence model in our case. So that is the thing. It is not working again and again. Now you can see my simulation start working and my convergence criteria of omega and all things k omega and for velocity and pressure they are 10 power negative 20. Now it should be run and the end time for my this case is let me open one more Ubuntu terminal and explain to all these things in that case.
Mhm.
Ubuntu, Ubuntu, okay, yes, here it's come.
What happened?
And,
I open a terminal.
okay,
It's the first one.
okay, okay.
Ubuntu.
Open.
And what it how when I know how I know when use epsilon, when use omega? It's
It's
according
depend
the
upon your problem.
conditions.
Joseph, it's depend upon your problem, what type of problem you have. For example, if
Mhm.
you are using a 2D or a 3D dimensions, then it depends what you need. For example, when you see in your literature review that in literature review, most of people use K omega and most of people use K epsilon. So it's your choice which thing you want to use, which thing or which plus model you want to use in your case. Okay.
Ah, okay.
But I think your Ubuntu terminal is not opening right now. I think because the simulation are started, so that is the reason they are not just coming. You can minimize. Okay, let me give you right so that you can minimize this thing. Give a motion. Okay, now minimize this Ubuntu terminal.
Okay, now finish.
Oh, I think you have your simulation or LS here just and enter. Okay, now right here explorer.exe space dot copy and paste.
Mhm.
Okay, and copy and paste at your desktop.
Okay.
Okay, delete first one and apply the second one.
What it?
I cannot see what has happened with your simulation. You have which one you have enabled? Okay, let me give first of all right. So how can I see which is happening? First, remote control, request, this thing, delete, and delete this thing from here, and the file, open, okay. First of all, let me enable this one. But I think there is still error in your simulations. They just fine, but still there is a problem with them. Let me display them from here so you can see. You cannot see any change in this case. That's yes, omega is okay. There is no problem with omega. And NUT, yes, it's okay. And with the K, yes, it is also good. K is working in a good way. So the only thing that is not working is P. Yes, none of P is also working in a good way. Okay, now let me show you some post processing techniques here. You didn't open the good file, I think, at that time. So that was the reason. Let me try this thing. Yeah. Now let me run some tests. Okay, now you can see this is how your simulation exactly works. Okay, so now let me try to apply some. So okay, this is how your solution goes. Okay,
Okay.
so these all are the words. So we will all do these techniques in our at the end of lecture one. We will go through snappy X-Mesh. We will go through all different techniques. Okay, now let me explain you about different things which are in the block mesh. Okay, your simulation are good. Up till now, if you have any question regarding this thing, you can ask me.
Well, no, maybe we're gonna do the same exercise with a snappy hash mesh, I guess, for compare what it, or
Okay.
it's not correct.
Okay, no issue. Okay, now can you open your block mesh directly? Sorry, not block mesh, your control directory. Close this thing. Open Ubuntu terminal. Open your open your system directory.
Oh,
ls here. Open your control directory. Okay, now you can define here, just it will come down here. Now you can see the start time is 0 here and the end time is 2000. Your simulation will all stop after 2000 iteration. Okay, so that is the thing with here, and after 100 time interval, your simulation are written in your cases. So the right control is 100. After 100 iteration, your one simulation will be written, and your change of interval or delta is 1. Okay.
yes.
Now just little come down more. Okay. Now the right precision is 6. What does mean by this? Have you any idea?
It's mean that the right precision that your values are written up to digit 6. For example, 0.000 up to 6 precision. Okay. Now just let come more down.
I changed that number 6 for 00.1.
No need to change, but I'm just explaining what does mean by this right precision. Okay.
Okay.
Now just it will come more down. Okay, more time. So what does mean by this runtime modify true? It means if your simulation are running and you want to change your something in your control dictionary, you can change. So this means runtime modify true. If you want to change anything in your current running simulation, you can change it. So that's a good thing in here in OpenFOAM 2021. In old version, they didn't provide this utility, but in these version, they provide this utility. Okay. So the
Ah,
and you can see the functions that in hashtag include function streamline. With the help of this function, you can write your streamlines in the paraview. Can you minimize this and open your paraview? Like to show how they are written in your open paraview and open pits daily. In pits daily, there is a folder name as post processing. Just directly go to that folder, post processing. No need. Just cancel it. What are you doing? Close it, cancel file, open and post processing. Just go to click over one more time, click. Now open the sets, open the streamlines. Okay, now just at the bottom, just open 2000. You see the number 2000 here at the top, 2000 at the up 2000. Yes, click here and I think you cannot see the files which are present here. Okay, let me give me rights. Let me see here. Just okay, accept this thing. You accept it. But I cannot also see. I think they have not written their these streamlines in this case. Uh, Let me open this thing and post processing sets streamlines and 1900. No, I cannot see anything there. So this function didn't write any streamlines in your case, but when we will set this function in your control directly, it will automatically write these streamlines in your case. Okay,
okay.
because they are already written in this case, we didn't change anything in the function in this case, so we cannot just simply define them like this, and we can include streamline function. So for this streamline function, you need a file, and in that file, you need to specify the direction in which cases you want. Let me open that file for you. Okay. So, fifth colon W U. Let's here. Now you can see the file streamlines here. Namespace streamlines. Okay, in this while you need to find tell about what is your starting point and what is your ending point. Okay, when we can assign them, now it's your homework. Okay, now you can define here the starting point. What is your starting point? For example, the starting point at your inlet. What are the minimum and maximum point of inlet, and what are your maximum and what are your total point at your end? Okay, now you can define them, and tomorrow you will show me your streamlines. Okay.
Okay.
Okay, that's good. Up till now, if you have any question and you need to change the number of lines up to 50, 100. Okay.
Yes.
Okay, now you can this is your homework. You can show me tomorrow. Okay.
It's okay, Wally.
Okay, so if you have any question regarding me, this lecture, today's lecture, you can ask until we can leave this class.
Uh, after this block mesh, we're gonna start with snappy hash mesh. It's okay, or
Now we are going to start tomorrow with your solver setting, and tomorrow is the lecture of your whole solver. For example, what does mean by the simple form, micro form, pimple form? These solver tomorrow I'm giving you an overview lecture of all those solver and their properties. And after that, we are going with the snappy X mesh. Okay.
yeah, okay, it's
Okay.
perfect.
Okay, perfect. Then we can leave today class. Okay.
Yes, it's okay.
Okay. Then bye bye. Take care. We will meet tomorrow.
See you tomorrow, Walid. Thank you a lot.
Thank you.